So now we'll talk about the event lists. So the event list is basically just a cool use of the observer pattern. So whenever the user does the data scraper register for tracking, saving, and displaying, what it does is it takes that, in this case a float data list, and goes and rolls it into these event lists, which all inherit from the same event list parent just for the sake of getting nice virtual functions and making sure everyone has the right storage types. So for scraping, whenever the event list scraping gets called, we can scrape float data. It'll go through every float data list or integer data list, and we'll just call scrape data, which calls that function that we were looking at before, for just scraping a new data point. And that's all protected from ACI, just so user doesn't get involved with it. Scrape integer data, insert float, and this is just management tools that are largely hidden from the user, just for me maintaining control of all this memory and references. Saving, largely the same idea as scraping. You have a runtime version where you're trimming it. This is called by the saving thread right here, which this is used if you have way too many data points, which the definition of way too many data points is this number of data points before unloading, which I set for 1 just for the sake of a demo. So when it gets to that extreme need to offload situation, it wakes the saving thread and says, hey, I need you to trim. So he goes through and trim everyone that he can, and goes back to sleep. And then when the engine is finally over, he wakes it, but this time he says, is data scraper running? False. So he just goes through and dumps all of the remaining things it needs to save. And for the sake of simplicity, the main thread will join the saving thread in this case, which I know is kind of inefficient, but because it's only on destruction, it's okay that they line up like that, and it guarantees a lot. It helps guarantee that these threads never have any sort of weirdness about who is ahead of who. So when I get to this point, I know that everything has been saved and offloaded. So that's what the saving does. Just you trim it if it gets too big. Otherwise, you wait until the engine ends and you just dump everything in one big batch. And then just tons of functions for inserting, removing, clearing. Displaying is a little bit different in the fact that he has this current display, which is my sprite string object that is just, it's my text object. But what I do is I take that text object and I go through every data list that I have in here and take his currently displayed, yeah, this is quite a long line. It's kind of a gross line. You get he's got data list ID, so that's how you get the name on the screen, and then you get the current displayed value. So that's whatever value you want to display, and you put those values into your sprite string, and you render it, then you go to the next one. Exact same thing for integer data, and then insert, remove, clear, just for the sake of keeping references and memory nice and clean. This guy should be using these buttons, which I don't have the asset for a button, and I'm out of time, so I'm just not going to. Sorry. Which you'll see in the numeric data buttons. These buttons I will get into more in my game demo in section. This is a class that I added in my UI overhaul. Or UI overhaul, but I added buttons basically. So whenever you click it, it will set for display min and max, current, average, but I just don't have an asset for these buttons, so I'm not using them currently. But if I did, the event list displaying would own them. It would own all of the buttons that are relevant to the... Oh, sorry. The data lists would own the buttons, because each one needs to have a button unique to it, so otherwise there are no weird references, no references that are breaking, and that you can dynamically remove them without having to update those references and messing all that up.